We're going to start with page 20 of the Algebra 1, page 1104. And I know that I've skipped several pages. Some of that stuff we've already done in the past. I'll try to go back and do some of those videos if I get time. But we're going to start with page 20, and we're going to work from here. So on page 18 and 19, we were doing simplifying the radical expressions. So your number 1 over on page 18 was the square root of 12, and how do you figure that? Well, what are factors of 12? You have 1 and 12, 2 and 6, and 3 and 4. So this is a square root. So what of those factors has a perfect square in it? And it is 3 and 4. So you have the square root of 3 times 4, which gives you 2 times the square root of 3. Okay, and that is your final answer right there. One of the ways I described how to understand this a little bit better, that is your final product, is to think of it as if you were doing 13 divided by 2. So how many times does 2 go into 13? 2 goes into 13 6 times. 6 times 2 is 12. And 13 minus 12 is 1. And then you have a remainder of 1. So 2 goes into 13 6 times with 1 left over. The square root of 12 is 2 with 3 left over. So think of it that way. It might make it a little bit easier for you, for those that are having some trouble with simplifying these square roots, cubed roots, and all that. If you think of it more as it's what you have left over that you weren't able to get rid of. It's your remainder. Okay, so over on page 20, these first 4, 1 through 4, they're very easy. It is just going back to what we've done before. So we can combine like terms if they're both the exact same term and the exact same exponent, such as a and a square. So a and a square are not the same, you cannot add them together. But you can do a plus a, which is 2a. And you can do a square plus a square, which is 2a square. It's the same thing when you're talking about these radical expressions. As long as your radical is the same and your index is the same, then you can add them together. So the number on the inside has to be the same, and the square root or cubed root or whatever your root has to be the same. That is your index. This is your radicand. Okay? So all of these on number 1 are the same. You have 8 plus 2 plus 1. Remember, there's an understood 1, okay? So this is going to equal 8 plus 2 plus 1 times the square root of 5. 8 plus 2 is 10, plus 1 is 11, times the square root of 5. And that is your final answer on number 1. Okay, so I skipped number 2. Again, all you have to do is find your common factor between 1 over 2, 1 over 3, and 1 over 6. And then you add those together, and then you just put that square root of 2 at the end. As long as everything is the same, you can add them together. All right, so I skipped down and I did number 4 because I just felt like some might not like this one because you're dealing with a whole number and then fractions as well. Okay, so what I'm going to do is I'm going to change this, and I'm going to just look at my fractions only. Still have my square root of 3 here, but I'm going to leave it off for the moment. I'm going to say 2 minus 1/3 plus 1/5. All right, so how do I add and subtract all those together? I've got to find a common factor. Or a common denominator, and that includes this 2. Okay, so I'm just going to go ahead and put 1 over 1 there. Why can I do that? Why can I put 1 over 1 there? Because 1 divided by 1 is 1, and 2 times 1 is 2. It does not change this answer any whatsoever. Okay, so I have 5 and 3. What is my common factor between those? Well, it's 15. Okay, so I got a 15, and a 15. Okay? So, now I'm going to say 15. On this first one, I'm going to do 15 times 2, okay? Because that is in my numerator, and that is 30. So my first one is going to be 30 over 15. How do I know that that is correct? Because if I did 30 divided by 15, what am I going to get? I'm going to get 2. So that is correct. All right, so 15 and 3. So that 15 goes, or 3 goes into 15 5 times. And 5 times 1 is 5. And then 5 goes into 15 3 times. And 3 times 1 is 3. So how you can know if this so far is correct is if you were to divide these out, divide this, divide this, divide this, you would get these answers, okay? 2 over 1, 1 over 3, 1 over 5. All right? So then what I'm going to do is I'm going to add and subtract as I need to. So I have 30 minus 5, which is 25, plus 3 is 28. So I have 28 over 15 times the square root of 5. Did I go too fast? I get accused of that a lot. So you can leave your answer like this. I would say go ahead and simplify it down because that's technically the rule of math in general is to simplify as far as you can go and don't leave improper fractions. So I'll change this to a mixed number. So 15 goes into 28. How many times? 1. 15 times 1 is 15. And then I have 28 minus 15 is what? Hope that you said 13. Bring over my 15. Oh, I don't know why I was putting the square root of 5. That's supposed to be a 3. And this is your final answer. Okay, if that didn't make sense, just start the video over, slow it down a little bit, do it step by step. But as long as your square root and your numbers and all that are the same, you can add these numbers that are on the outside. All right, so moving on over to page 21. So I skipped number 5 because it does all the breakdown for you. And I moved on to number 6. It kind of does the breakdown for you in this one, but 7 and 8 are very simple. You should be able to do those without any help at all. But number 6 has a little bit of complication to it. So I was going to do it. And I'm going to do it like I would do it if I were to be doing this problem. Okay? So remember, I cannot add these together because they are not the same. That's an 18, a 32, and a 50. They're not the same. I know that I can't add them together, so I want to try to break these down a little bit more. Also remember that this is 3 times the square root of 18, 2 times the square root of 32, and 3 times the square root of 50. So anything that you bring out, anything that you get the square root of, has to be multiplied by 3, has to be multiplied by 2, or has to be multiplied by that 3, okay? So we're going to start with the first one, 3 times the square root of 18. So what are your common factors of 18? So I always start with the lowest, which is 2. And does 2 go into 18? Yes. How many times? 9 times. Is 9 a perfect square? Yes. 9 is a perfect square. How do I know that? I just go through all of my perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And I just go on like that. So it's easy to find my perfect squares. Remember, a perfect square is anything multiplied by itself gives you that number. That number is the perfect square. Okay? So factors of 18 are 9 and 2. Which turns out to equal the square root of 9 is 3. So I have 3 times 3 now times the square root of my remainder, or what's left over, which is 2. There is no square root of 2, so that part is done. But now I just have to finish that. So that's going to equal 3 times 3 is 9 times the square root of 2. Okay? Let's go on to our next one. So I'm done with this one. I've solved that one. Let's go to the next one. 2 times the square root of 32. So just a little trick here for you to know for this moment. This can change as the book goes on and as Algebra 1 goes on, and even when you get into Algebra 2, this concept can change. But at this point, these problems, the book is not going to trick you. So every one of these, what's left under the square root is going to be 2. Or it's going to be the same, like not all of these problems. But in this case, what's left over is 2. So I know that I'm going to divide 32 by 2, and I know I'm going to divide 50 by 2. Because the book's not going to trick me at this moment. Okay? So when I divide 32 by 2, what do I get? 16. Okay? When I simplify this more, I have 2 times the square root of 16 is 4, and then times the square root of 2, which is then going to equal 2 times 4 is, oh, I was going to change that to black, 8 times the square root of 2. Okay? And now we're going to move on to the last one, which is 3 times the square root of 50. Remember, we've already established that I'm going to be dividing by 2. So I have 3 times 50 divided by 2 is 25 times 2. The square root of 25 is 5, which then is going to equal 3 times 5 is 15 times the square root of 2. Okay? So if everybody's gotten to this point so far, we can now get to our final problem, or the final answer. So in our final answer, we're taking these numbers right here that we just got, and we're going to plug them back in for the appropriate numbers here. Okay? So which one was my 3 times the square root of 18? It was 9 times the square root of 2. So 9 square root of 2. I had a negative sign, so I'm going to bring the negative sign. Now I have 8 times the square root of 2. Bring down my negative. And then my last one is 15 times the square root of 2. So the final answer is 9 minus 8, which is 1, minus 15 is negative 14 times the square root of 2. And that is your final answer. Okay? So moving on and doing number 9. Number 7 and number 8 are very much the same. Once you figure out what is left under your square root, everything else is going to be that same way. Okay? So number 9. 6 times the square root of 54, 3 times the square root of 24, and 2 times the square root of 6. All right? So I'm going to write all these out down here. 6 times the square root of 54. Then I'm going to do 3 times the square root of 24. And then I'm going to do 2 times the square root of 6. All right, so when you're looking at this, what's the first thing that you notice? And I hope that you notice something. There are no factors of 6 that end up with a perfect square. The only factors of 6 are 1 and 6 and 3 and 2. And neither of those are perfect squares. So what does that mean? That is going to be left under my square root. 6. So I'm going to divide 54 by 6. And what is 54 divided by 6? Okay. The square root of 9 is 3. 6 times 3 is 18 times the square root of 6. Okay, so that's my first one. All right, so now I've got this 3 and 24. So we've already decided that 6 is going to be what's left over. So 24 divided by 6 is 4 times 6. The square root of 4 is 2 times the square root of 6. 3 times 2 is 6 times the square root of 6. And then we've established that this one is what it is. So now I'm going to put these back into the original problem and in their original spot. You have to put them back in where they came from. This one goes to the first one, this one goes to the second one, and then this one obviously goes to the third one. It didn't even change. All right, so I'm going to have 18 times the square root of 6 minus 6 times the square root of 6 minus 2 times the square root of 6. And then I'm going to solve. So 18 minus 6 is 2. I'm sorry, it's 12. And then minus 2 is 10 times the square root of 6. That's your final answer. All right, hope that makes sense. We'll do one more. We'll go over to page 22. And I will do number 11 on page 22. I'm doing number 11 because it is the cubed root. So it changes it up just a little bit for you. And that's fine. We're just going to go with it. Okay? So when you're talking about the cubed root, remember that's 3 numbers. The square root is 2. 2 times 2 is 4. So the square root of 4 is 2. All right? So when you're talking about cubed roots, you're doing 3. 2 times 2 is 4 times 2 is 8. That's 3 2's. So the cubed root of 8 is 2. All right? So we're really doing the same concept here. Is you just are having to go one step further. All right? So let's work this out the same way that we did the others. We're going to bring it down. We're going to do the cubed root of 16. We're going to do 2 times the cubed root of 128. And then we're going to do the cubed root of 54. All right? Now, going back to the first one, we have 16. So what are factors of 16? We have 4 and 4, 8 and 2, and then 1 and 16. So it's not 4 and 4, because remember we're working with the cubed root, not the square root. But 8 and 2, is that the cubed root of something? Is that a cube of something? And the answer is yes. We just said that just a second ago. All right, so you have 8 times 2. 8 times 2 is 16, and the cubed root of 8 is 2. Okay? So you bring out your 2, and leaves you with your 2 on the inside. Okay? So 2 times the cubed root of 2. Move on to your next one. So if we have a 2 inside here, that means there's going to be a 2 inside this one. So what is 128 divided by 2? 64. And what is the cubed root of 64? We know there is one. It is 4. So you have 2 times 4 times the cubed root of 2. And 2 times 4 is 8 times the cubed root of 2. Okay? So there's one answer. There's 2. And let's get our third. So again, we're going to divide by 2. Because we know that's what we're working with. So what is 54 divided by 2? 27. Hope that you agree. So what is the cubed root of 27? What times what times what gives you 27? Hope that you said 3. If you did, you're correct. If you're still working it on the calculator, Learn your multiplication tables. 3 times 3 is 9, times 3 is 27. That's how I come up with that so fast. All right, so there's our third number. So now we're just going to plug these back into the appropriate spot. So my first one is going to be 2 cubed root of 2 plus 8 times the cubed root of 2 minus 3 times the cubed root of 2. So 2 plus 8 is 10, minus 3 is 7 times the cubed root of 2. Final answer. Okay, so I hope this video helps you with these few pages, 20, 21, and 22. It does seem like a lot, but it's not once you kind of figure out a rhythm. Once you get your rhythm, then you're good. But getting that rhythm sometimes is kind of difficult, and then you'll get into a rhythm, and then they'll throw you off by doing this cube root and doing the fourth root. But don't let that throw you off. Don't panic. Just keep going with it, okay?